Okay, so our next video is about translations, which is another type of transformation. And the first thing to consider is vectors, which you've seen before. A vector is just a line segment with direction and magnitude. So when we put in the vector notation like this with these brackets, that means that, let's see if I can circle that. Okay, so that means that you would start from wherever you were and go 3 to the right and 1 down. You're used to starting at the origin and then maybe starting at the end of another vector, but just generally speaking, this means that you go 3 to the right and down 1. So what we do is take any major points, like what we did before, taking the major points and following the slope of the perpendicular line to map them. I'm going up to the line and then going over. It's the same thing, but this time we're just taking those major points and moving them. So we're not flipping them. It's just like if it was a little triangular sheet of paper or a little trapezoid-shaped piece of paper. You pick up the paper and you move it over. And that's what a translation is. So it just moves it, and that's it. So in this case, with this one, to the right, 3, down 1, lands you there. And the question of does the vector start at the image or the pre-image? Well, we talked before about how the words mean what words normally mean, and pre means before. It's the place you start. So you start at the pre-image. And even if you didn't think about it that way, if you look at these, if you look at A, for example, if one of these went right and down, it was this one. So this one is the one that where the vector started, and this one's the one with the primes. So remember that these little primes mean the image, and without the prime, it's the pre-image. So the vector started at the pre-image. This one went to the right 3 and up 2 because the 2 is positive. So you would take each point, A, 1, 2, 3 to the right, 1, 2, up. And you would do the same with B, C, and D, and then you'd put the prime. Same with this one. You start with this one because it doesn't have the prime, and you go to the left 2 because of the negative 2, and then up 2. So over here, that one's left blank. So what did we do? We start with A, we land at A prime. So to get from one to the other, we would follow this path. So to the right 2, and then down 4. So 2, negative 4. Positive 2 because we went to the right, negative 4 because we went down. So this one, we want to translate the triangle RUN, and the vector is 7, negative 3. So each one of these points goes to the right 7 and then down 3. So for U, 1, 2, 3, 4, 5, 6, 7, down 3, 1, 2, 3. U prime. Well, my U is tiny and my prime is huge, but that's fine. So R, 1, 2, 3, 4, 5, 6, 7, down 3, 1, 2, 3. R prime. N, 1, 2, 3, 4, 5, 6, 7, down 3, N prime. And there we have triangle R prime, U prime, N prime. So the question of, is a translation an isometry? Remember that isometry means equal measure. So it means I haven't made it larger, smaller, stretched it, skewed it. And like I was just saying before, and like you can now see with translations, we're just moving it. So nothing should have changed the size of anything if I just move the triangle over and down. So a translation is still an isometry because it keeps all the distances and measures the same. Now, here's a question about one triangle and the other triangle. Because it's an isosceles triangle, if it wasn't labeled, you might not know if it was reflected or translated, because I can move the triangle over and it looks the same as it did before, or I can flip it over and it looks the same as it did before because it's isosceles. So it looks like it could have been either one. But the thing to note is that r and r prime are both on the left, and t prime are both on the right. If I'd flipped it over, then r would have been the one over here. So this would be r prime, and it's not. So this was a translation because everything stayed in the same orientation. Now, what would be the image of a point, 1, 3, if it's translated along the vector negative 3, 5? Well, I would subtract 3 from 1, and I would add 5, because 3 is negative, it's negative 3 and positive 5. So that would be negative 2, 8. So that's where P would go under that vector translation. So now, instead of saying, here's a point, where does it go when it's translated, we're given where it was translated to. So negative 6 moved to negative 4, and negative 2 moved also to negative 4. So negative 6 plus some value led to negative 4, and negative 2 plus some other value led to negative 4. If I solve for these, I've solved for the vector. So the question is basically, what did I have to add to negative 6 to get to negative 4? Well, I had to add 2, and the way you find that out is by adding 6 on either side to solve for k. Over here, what did I have to add to negative 2 to get to negative 4? In this case, it's negative 2 because I actually went further down. So adding 2 to both sides, h is negative 2. So the vector is 2, negative 2. If I use that vector to translate the point 3, negative 1, I get 3 plus 2, minus 1, minus 2, 5, negative 3. So now we want to know what vector would we have to use to take r to u. So I'm going to start with r, and I want to move to u. So to get to u, I have to move over 4 and up 1. And then how would I get from u to n? I would go over 2 and down 4. So 2, negative 4. To get from r to n, I could go 1, 2, 3, 4, 5, 6, and then down 3. But another path I could have taken is to go from r to u and then to n. So actually, if I just added these two together, I would have already gotten this. So that would be taking a different path, going like that. But those two vectors together are a path from r to n. So if I take this vector and add this vector, I get this vector. Oops. Go back. Oh, wrong way. Okay, so how do the first two relate to the third? We just discussed that. If you add the first two, you get the third. So you can use that pattern by, if you know I'm going to take one vector and then another and so forth, that you can just add them up, and that'll give you the total vector path. We want the image of the point 2, 4 after it's translated using the vector 4, 2, then negative 3, 1, then 5, negative 6. So there are really a bunch of different ways you can look at it. You can say, okay, well from 2, I'm going to add 4, then subtract 3, then add 5, which will give you then 6, 3, 8. And then from 4, adding 2 is 6, add 1 is 7, subtract 6, so it should be 1. You can also say, well, if I'm going to take 3 vectors, I don't know how that 11 got there. I'm going to take 3 vectors all together, then you can say, okay, so the total vector is 4 minus 3 plus 1. This is what we just learned on the previous slide. 2 plus 1 minus 6. So that's the total translation vector there. So 2, right? 1, 2, yeah. That should be a 5. 2 plus 1 minus 6. So 1, 6. Try this again. 6. Well, that's just stuck. I don't know how to fix that. Okay, so that's a 6, we'll assume. And then 2 plus 1, 3, minus 6, minus 3. So our total translation vector is 6 minus 3. So then 2 plus 6 is the 8, 4 minus 3 is the 1, and we get the same answer. On 11, we have the point 2, negative 7, which ended up being negative 6, 3, after we added. So 2 plus something was negative 6. So what we can do, instead of doing the solve for h, solve for k, we can skip that step and say, okay, negative 6 minus 2. That's what I had to add to get there. So it's going to be minus 6 minus 2, 3 minus a minus 7. So negative 8, 10. And then you can check it. 2 minus 8 is minus 6. And minus 7, or plus 10 is 3. Now we want the image of xy after we translate it using the vector 4, 2. So we don't know what x is, so we can't really add these and just write a number down. But whatever it is, it's going to be x plus 4, and this one's going to be y plus 2. Okay, so that's going to bring us to part 3 rotations, so I'm going to stop and restart.